Hello and welcome back to Unit 3 Vocab. I don't know what I'm going to call it in Schoology. That doesn't make any sense. Unit 3 Vocab. Yeah. We're getting somewhere. Alright, this is going to be a little bit different to save on printing costs. I'm going to give you blank paper and you're going to build your own with the big rulers. Please do not slap the big rulers on the desks. I will give you detention. You have to come in and clean the desks after school. So what you're gonna do is you're gonna make these boxes. How many boxes do you need? 5. 5 rows. 3 columns. That's 15. 15 boxes. Okay, this last box is bigger than all the rest, but that's alright. Here we go. Ding, 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 ding. Okay, some of these are going to be review, but that's good to have all these concepts down. A linear pair is 2 angles which are adjacent and supplementary. And which means they add to 180 degrees. They're very useful because wherever you have a straight line and a line that's coming off of there, you have this situation. So this situation comes up a lot. Adjacent, of course, means they share a ray. So this first angle goes from here to here, and the second angle goes from there to there, and they make a straight line on their other rays. Right. Switch it up here for a second. I think we've done axiom before. A synonym for axiom is postulate. And these are statements that are accepted as true without a proof. So also sometimes we call them basic understandings. Things like vertical and horizontal lines are perpendicular. I can't prove to you they're perpendicular. That's just what they are. Either you accept it or not. Or straight lines are straight. Or lines exist. These are postulates or axioms. Postulate comes from a Latin word for to ask. So it's like asking a question. What's the answer? Axioms come from like proper thought, or what is things that are fitting, like correct. Like axioms are just correct. Like parallel lines never touch. That just seems correct. Correct, let's say. And what else do I want to say about this? Oh, it's possible to postulate things. It's a verb too. Postulate things that are not totally foundational, just so you can go through an argument. And that, in that sense, it's kind of like a conjecture. One other thing is postulate is especially for geometry, because one of the first geometry books used that word. But lots of mathematics uses the word axiom, and they're basically the most fundamental things that the rest of mathematics is built upon. what should we have a postulate that we were using, that the corresponding angles postulate. That angle A is congruent to angle B. I can't prove that to you, but if you could believe it, especially because if we use translation and we translate this intersection up to this intersection, you'll see that they are A and B overlap exactly. By the way, these have to be parallel for this to work, right? Okay. So we're gonna build a lot of knowledge upon this postulate about this, or also even that a linear pair adds up to 180 degrees. Well, they're along a straight line. Straight line has 180 degrees in it. That's just been postulated as true. But from these postulates, these basic ingredients, we can begin to build theorems. These are statements derived from the postulates and logic. An example, the vertical angles theorem. So lots of times I'll just show students two lines crossing and just say, look, the angles that are across from each other are congruent. You should just accept it as a basic understanding, like a postulate or an axiom. But actually, this can be proven based on a more fundamental postulate that straight lines have 180 degrees in them. So this has 180 degrees, and this has 180 degrees. That means A plus B equals 180. I should have measure. I'm in a hurry now, so I'm not going to do measure of angle A and measure of angle B. I'm just going to say A plus B. And B plus C equals 180. But if we isolate B here and substitute it in, we get A. So we're substituting 180 minus C equals 180. Then we subtract 180 from both sides, and we get A minus C equals 0, plus C to both sides, and we get A equals C. So we were able to prove the vertical angles theorem. What you will sometimes hear people say is, mathematics is like a book that writes itself. Once you have the axioms, everything else is discovered after that. Or is it invented after that? I don't know. The debate rages on for thousands of years. Very fascinating. All right, let's get into our, oops. So we're going to do corresponding angles. That's the key concept. These have got to be parallel. Oops, I did the picture first. Oh well. So A corresponds with A prime, B corresponds with B prime, C corresponds with C prime, D corresponds with D prime. And notice B and D are vertical, and B prime, D prime are vertical. So those four are all congruent, and C and A and C prime, A prime are all congruent. Same angle in same place where the transversal crosses parallel lines. And lastly, oops, I keep trying to draw the diagram here. Let's do alternate exterior angles. So A and B. I did it again. I put the diagram in the definition slot. That's what I get for making my own paper. A and B, you can trace this. You can take this over here to A prime is vertical, so it's congruent, and then now they're corresponding, so they're congruent. So A is congruent. I'm going to put angle A is congruent to angle B. Those are alternate exterior angles. Why are they exterior? Exterior, outside the parallel lines. Not between them. Alternate opposite sides of transversal. All right, take a picture, upload. Nice job.